welcome to the Explainer. Look, today we're doing something a little different. We're not just reviewing, we are speedrunning the entire AWS Compute module. And we're going to be laser focused on exactly what you need to know to pass that SAA CO3 exam.
So think of this less like a lecture and more like a workout for your brain. It's an active test of what you really know. We're going to find any weak spots and get you totally exam ready. All right, let's get into it.
All right, first things first, we're going to do a quick warm-up. Let's get our heads in the game by covering a few of the absolute must-know concepts. And we're starting with the real foundation of AWS Compute. Yup, EC2 Instance types.
Okay, so on the exam, they're going to throw a workload at you, and you need to instantly know which instance type fits. That's where this little memory aid, CramFacts comes in handy. It covers the key families you got to know. Let's just run through the big ones, right? C, that's for your compute-intensive stuff. R is all about RAM. M is for main or general purpose, kind of your jack of all trades. T is for tiny, those burstable instances. P and G, think graphics or machine learning, that's your GPU. And finally, I and D are for IO-intensive workloads with tons of storage. Seriously, if you can nail these pairings, you are absolutely golden.
And then there's the other side of the coin, pricing. Look, knowing when to use a spot instance versus, say, a reserved instance, that's not just about saving a few bucks. I can pretty much guarantee you it's going to be on the exam. So really pay attention to the use case and whether or not it can be interrupted. Okay, warm-up's over. Now for the main event. We're going to tackle some real exam-style scenario questions. This is where we separate the pros from the amateurs. All right, first scenario, the exam is always giving you clues. Always. Here, the keywords are tolerate interruptions and minimize costs. I mean, they're practically screaming the answer at you. Think about it for a second. Got it? And the answer is spot instances. If you got that, nice work. But here's the thing. It's not enough to just know the answer. For the exam, you have to understand why it's the only possible correct choice. It's pretty simple, really. Spot instances were literally designed for this. You're telling AWS, hey, I'll take a massive discount, and in return, you can interrupt my job if you need the capacity back. For things like batch processing or anything that can be paused and restarted, it's just a complete no-brainer. Huge savings. Okay, next one, same drill. Hunt for those keywords. Now, high availability, that's pretty standard for most load balancers. But the real giveaway here is advanced HTTP/HTTPS routing. That phrase should immediately make you think of a specific layer of the network stack. And boom, it's the Application Load Balancer, or ALB. If you nailed that one, awesome. Now let's quickly unpack why the other options just don't cut it here. So the ALB is what we call a Layer 7 load balancer. That means it's smart. It can actually look inside the web traffic at the application layer. This is what lets it do cool tricks like path-based routing, sending everything for /API to one set of servers and all the /images requests to a completely different set. The other load balancers, they can't do that. Okay, new problem. Your app traffic is all over the place, and you need to keep the average CPU right at 50%. The key here is you want to maintain a specific metric without having to babysit it. So what's the set it and forget it policy for that? That would be target tracking scaling. On the exam, when you see a question about maintaining a specific metric like CPU or request count, this is almost always your answer. It's the simplest and most efficient way to do it. Yeah, with target tracking, you're literally just telling auto-scaling, hey, my goal is 50% CPU, you figure out the rest. And it does. It handles all the CloudWatch alarms, all the scaling actions, everything. Super simple, super elegant. Okay, we've worked through a few scenarios. Now let's switch gears and test your raw speed. All right, time for the lightning round. No more stories, no more deep dives. This is pure rapid-fire recall. Just question, answer. We're building that mental muscle memory. You ready? Let's go. First up, a classic. AWS loves to ask about service limits. Yep, 15 minutes or 900 seconds. Remember that. If your function needs to run longer, Lambda's not the right tool for the job. Okay, next question. Think raw network speed, think predictable IP addresses. The Network Load Balancer. That's your Layer 4 workhorse. Perfect for when you need crazy high performance or a static IP for things like whitelisting. Okay, I know we already hit this one, but it is so important I have to ask it again. What's the absolute most cost-effective option for workloads that can be interrupted? Spot instances, no question. And remember that number, savings of up to 90%.
That's a key exam fact. Great work on that lightning round. Seriously. Okay, let's bring it all home now. We're going to boil everything down to the absolute essential takeaways for the compute part of your exam. So if you only remember 5 things from this whole explainer, make it these. 1. For smart Layer 7 routing, you want an application load balancer. 2. For raw speed and static IPs at Layer 4, it's the network load balancer. 3. If your job can be interrupted, use spot instances to save a ton of money. 4. For simple set-it-and-forget-it auto-scaling, use target tracking. And 5. Limit functions timeout after 15 minutes. I'm telling you, if you can walk into that exam and just nail these 5 points, you're going to crush a huge chunk of the compute questions.
So there you have it. You've just proven you've got a solid handle on the fundamentals of AWS Compute. The big question now is, what's next? Are you going to tackle storage, dive deep into networking? Whatever it is, keep this momentum going. You've got this. Good luck with your certification.